Hello everyone, welcome to the next tutorial. In this tutorial, we are going to find the total resistance and the voltage division of the resistors when they are connected in series with each other, okay? So let's say we have a electrical circuit over here. Let's say this is the voltage source Vs and two resistors R1 and R2 are connected in series with each other, okay? Let's say the total resistance, of the combination is equal to R equivalent. So, and let's say a current, let's say this is the loop and this is the direction of current, say I, okay. Let's say this is the voltage drop across the resistor R1, which is V1, and the voltage drop across the resistor R2 is V2, okay. According to KVL, Kirchoff's voltage law, Vs minus V1 minus V2 will be equal to 0, okay. So negative sign is applied to V1 and V2 because the current I is moving from the positive terminal towards the negative sign, okay. So there is a potential low over here. So this means Vs will be equal to V1 plus V2. So we know that according to Ohm's law, V is equal to IR, okay. So V1 will be equal to I into the resistor R1, okay. Similarly, V2 will also be equal to I into R2. So this equation, and Vs will be equal to I into the total resistance, which is R equivalent. So after substituting these values in this particular equation, what we can get is I into R equivalent will be equal to I into R1 plus I into R2, okay. So R equivalent will be equal to R1 plus R2, okay. So this is the total resistance of the resistors when they are connected in series. So it means that this implies if there are n resistors which are connected in series, okay, so the total resistance of this particular combination will be equal to, so the total resistance R equivalent will be equal to R1 plus R2 plus R3 up to so on plus Rn. So this is a very important expression of the resistors when they are connected in series with each other, okay. So now let's find the voltage division among the resistors. Let's find the voltage division, okay. So according to the equation, what we can say is I into R equivalent is equal to I into R1 plus I into R2, okay. Or you can say I into R equivalent is equal to your Vs. So Vs is equal to I into R1 plus R2, okay. So I will be equal to Vs upon R1 plus R2, okay. So this is the first equation, okay. So according to Ohm's law, what we can see is like V1 is equal to, so V1, the voltage V1 is equal to I into your R1, okay. So it means that on substituting the equation 1 in this particular equation, what we can get is V1 is equal to V into R1 plus R2 into R1, okay. Similarly, V2 will be equal to V upon R1 plus R2 into R2. So these are also very important expression, okay. So it means that, so what we can say is if there are n resistors in a particular circuit connected in series, so the voltage division of the nth resistor will be given as, so it will be given as Vn will be equal to V of S, or V, or the total voltage, divided by R1 plus R2 plus so on Rn into Rn. Okay, so this is also one of the most important expression, and I hope you get a clear idea how the voltage has been distributed when the resistors are connected in series. Okay, so that's all for today, guys. I will see you in the next lecture. Thank you.